Oh, hi, attendees. Good afternoon. Thank you for coming. Thank you for sparing this time. And this is Gurpreet, your host from Jinsol today. Thanks for joining us for this educational series and an amazing webinar that we bring to you regarding the bifacial modules. We have our panelists an introduction. We have Ms. Chris Liu from Longi Solar. We have Mr. Sai Charan from Jinko Solar, and we have Mr. Bhatt from Wari. So each of them will be giving their own perspective. Good, amazing players in the market. They have been in the Indian market for long, strategically very important for us. So we get them to share their point of view on this technology. So great. So a quick introduction to Gensol. Gensol is into Indian solar market since 2010. And we are into consulting practice, we are into operation and maintenance, and we are into project management consulting. We are also into a lot of knowledge sharing as part of our consulting practice. White paper, very specific bifacial technology in the PV modules. And that is something that this session would focus on. So very quickly, let me bring up the screen and just a second. All right. And before we begin, I just hope everybody's safe and sound. Very tough times around the world. And we thought this is a good opportunity to bring some learnings, some of the learnings from our side, from the industry experts to you guys. So here we are. All right. So Gensol did this white paper in the early March around the bifacial gains. A very quick introduction to bifacial technology. Meanwhile, we have this modules which are generating on both the sides. So conventionally PV modules, so far they always have been having a monofacial side. So imagine a solar cell being also put on back of it in the simplest possible terms, and it gathers some radiation from the backside and also generates, and it doubles up almost the capacity and the power that we have. All right. So this is a brief introduction towards end of the webinar, and in the emails that we send you, we are going to share a link of this white paper also. It's a good read. It has a lot of data, which is a little tough to shrink in this time, but I'll try to explain as much as possible. So for the sake of this white paper in the bifacial technology, we have assumed that these PV modules are mounted on a tracker system, and we have anticipated the gains. The gains are pretty high, so from 4% to 10.5% on a case-to-case basis that we're able to achieve with this configuration. The background, how we simulated this. So this is a desktop simulated data recreating the scenarios. So it is done on the most popular tool globally, which is PVSys software. And PVSys came up with the bifacial simulations almost 2.5, 3 years back when the bifacial was gaining, and it is still used globally to simulate that. While going through the detailed sessions, we'll also have a perspective of the industry experts that they have some real world examples to share with us, right? So we'll try to compare that, whether they match with the PVSys simulation or how do the on-ground results look like. All right. In the simplest possible terms, if we look at how do we calculate what is the generation gain from our PVSys, we have to calculate what we are generating on the front side, add it to the back side, and that gives us the total bifacial gain that we have, right? On the front side, as we know, we have solar radiation coming in, which is the direct radiation that falls on it. We also have a diffuse component, which is from the reflection, the cloud surfaces, the building objects around it. So that is what we have on the front side. On the back side also, a similar thing happens, but the key role which plays into the backside generation gain is the kind of soil, the kind of ground we have. Now you imagine that you put in a desert or you put it in snow, it is going to have a very different results in case of a bifacial project simulation. Reason for that is snow is going to reflect a lot more light, which the bifacial, the back side of it captures, whereas the front side almost remains similar. So this is a mathematical formula which calculates. This is more of theoretical. At your leisure time, you can go through it, but it's basically the G plus, which is the gain on the front side, plus gain on the back side, which gives you the total output of a bifacial module. All right, for this specific study, we try to compare three key locations, and we roped in the Middle East also into this. So we are simulating it at Bhadla Solar Park in Rajasthan, one of the biggest ones. On the extreme south side, we have Pavagada Solar Park. And from Middle East, we have the solar park in UAE, Mohammed bin Rashid Al Maktoum Solar Plant Park. So this is where we have tried, and the assumptions being used in this is that we have taken a project of around 3.1 to 5 megawatt peak. Reason for taking this specific one is because of the inverter configurations which are available in the market. So we have just taken with one inverter to keep the project simple. But as we know in solar, it is pretty scalable, right? So if you increase, you put 10 inverters, the gain is going to be almost similar. So that's what we have done. We have assumed a module watt peak of 360 watt peaks, although currently our panelists will tell you they have achieved really good numbers. Um, we have taken fixed tilt, we have taken single axis tracker, try to have a mix of the configurations, and an overloading also of around 40%. All right, the key input which goes into bifacial design is the ground surface and albedo values, right? So ground surface, very broadly, you can classify between snow. The best albedo values you're going to get from snow, which is white and gives maximum reflection, and the least possible being the dark and wet soil. All right. Let me quickly take you to the graph, and we are going to analyze this in some buckets, that which factors are impacting the generation and which method. So if you look purely on the impact of the ground surface, what the ground surface is having the impact on the generation gain, you would see it is pretty linear in nature, I would say, and it easily crosses 16% if you keep going, but that's in the best case scenario of snow, which is very limited geographically. So from Indian context, this only makes sense if you're simulating this for the lay end of that tender, which was happening, but only in the snow scenarios. But I think the bucket which we have on the front side is generally we witness across most of the locations. So you can see minimum, and even in the dark and wet soil, we're getting a gain of around 4.51%, and it increases almost in a linear manner. So this is the impact of the ground surface. There's also the impact of the pitch, means the row to row distance that you have. And this is from a perspective that the more the space you allow the backside of the module to get the generation, the more generation it has. Here you can see it is still linear, but the gain is not much, but still it is worth factoring in. So you can easily see that increase in pitch by 1 meter, you can see you're able to increase the incremental gain is almost 2%, which is pretty high. Right, so this is on the pitch side. Another impact, once again, from the backside analysis, if we see, so if we increase the height of the structures, right, so it is going to increase the albedo value. And here also you can see that the increase of height of the structure by 1 meter, it gives you again a good generation gain, 1.09%, in UAE up to 1.67% also. So although here also it is pretty linear with respect to height, but it contributes anything in excess of 1%, the impact of height of the structure. Geocoordinates, we also try to see, so as you move from Pavagada to the UAE solar park to Bhadla solar park, there's a little bit impact that latitude also has on the project, and that is also being captured here. So it is relatively linked to the tilt of the angle and tilt angle of the PV panels, and it subsequently has an impact on the light, the radiation that the backside is capturing. Okay, so here we have tried to accumulate the comparison, and you can very clearly see it is there's a significant gain which is expected in these kind of scenarios. I can understand this was a little time for you to absorb all the numbers, but we'll be sharing this white paper with you, and we are always there to address the questions. A quick thing, I can see a lot of attendees having raising their hands to ask questions. So I forgot to mention that. I must mention that now. I would request to keep posting your questions in the Q&A session, in the Q&A section, which you have at bottom of your Zoom control panel. And towards end of the session, we have a dedicated 10-12 minute slot where we would answer all the questions. and we'll redirect it to the specific experts. Okay, so that is there from the Gensol side, and I would welcome Chris Liu from Longi Solar. And Chris, over to you. You can share your screen. Chris, you can unmute yourself.
Okay, can you hear me?
Yeah, pretty much.
Okay, thank you. Thank you all for joining today's webinar. And this is Chris from Longi Solar. I'm very glad to be here to speak to you from China, from Shanghai. So at this special circumstances that we cannot visit India. So this is a very good opportunity for us from China to share this our experience on the bifacial technology and our new product series. For new. So I think Jinso just explained the system design of the bifacial modules. So for the first part, I want to explain what is the bifacial cell and module and how it works and how it can generate more energies from the backside. So firstly, the questions are always been asked, what is a bifacial cell and why it can generate energy from the backside. So first, let's take a look at this picture. So the first one is a monofacial PERC. So we have front side and back side, and then the downside is for the bifacial PERC. So generally speaking, the front sides of these two cells are the same, but the difference is from the back side. So you can see for monofacial, the back side of the cell are covered by a layer of aluminum, which can reflect the light goes through the wafer, backside to the wafer. But for the bifacial cells, the backside aluminum have a shape of the fingers. It can collect electricity from the wafer. But also we have, you can see the light blue from the backside. It is a passivation layer. It also has the function of anti-reflection layer. So this is a more detailed picture, the profile of the bifacial PERC. So the front side is almost the same. We have fingers, we have PN junction, we have ARC. But for the back side, you can see the blue layer. The blue layer is, we have a stack layer. The first layer is aluminum oxide. It's called a passivation layer. And the second layer is silicon nitride. It's for the function is anti-reflection layer. So with these two layers, the cell can absorb the light from the backside and generate electron and holes in the PN junction. So about the module side. This is the typical photo of the backside of the bifacial modules. So the backside, like the back sheet, is replaced by a glass. And the junction box, the split junction box in the center of the module, and the module also with the frame, because you know, in old times, maybe 2 years or 3 years ago, the bifacial modules are double glass without frame. But in the real application, that because maybe you can get a lower price when you purchase the module without frame, but in the real application, you will found that the break rate of the frameless module is a little big, so which you can lost part of the BOS part. So Longi offers module with bifacial modules with frame, which can you can easily install, and you can get a ground with in a simple way. And also it's offers a better mechanical loading for the bifacial for the modules. And it's also compatible with most of the mainstream tracking system. So next part is about the system design. I think Gulpit from Jinso already explained a lot. So let's quickly go through this part. So this is a typical system, bifacial system. We have a module here. We have a installation at the back side. So and we also have a light can directly on the shines on the module, and also some of the diffused lights will be reflected by the ground, by the clouds, or by the building near the station. So there's some key design parameters of the bifacial system. So firstly is the ground albedo. Here's some typical albedo data for different grounds. So you can see mostly in like a region in Middle East, they have a very dry sand. And some region like North India have a lot of snow, which will have a very good albedo for the bifacial system. And the second one is the height of the module. From this chart, you can see this shows the relationship between the height of the module and the bifacial gain. So normally we can see when the height is over 1.2 meter, the curve goes flat. So we recommended that the module height should be higher than 1 meter, because when the height is high enough, the radiance at backside will be very even. So next part is about the GCR. GCR, the definition of GCR is the shed width divided by the area pitch. When the GCR is lower, that means in some fixed region, the less modules are installed. The GCR will be lower, and the lower GCR have a higher energy gain. This, I think, is a very easily to understand that when the space between the rays is big enough, then enough lights can be reflected to the backside of the module. Also, important part is about the DHI. DHI is the diffused horizontal irradiance. As I mentioned, the light have two parts. The sunlight has two parts. One is called the direct light, and one is called the scattered light. Also here we can call it a diffuse horizontal irradiance. So the region, let's consider the same ground albedo. The higher the DHI ratio is, then the higher the bifacial gain will be. So the last part is about the shading. When you install the module, no matter it's on a fixed tilt or on a tracker, there will always be a supporting ray or supporting torque on the backside. So first, if you have a supporting beam on the backside, please avoid the center of the cell, because like Longji's HIMO 4 product series, the bifacial modules, we have a half-cut design, which means that we have the junction box in the center of the module. So this means we can avoid the shading caused by the torque in the center. So we also recommended that the supporting system should be at least 40 to 50 millimeter from the backside glass. Also, the cable connection also will cause the backside shading. I think the portrait installation is the most common installation method in India. So you can see from this picture that when the cable length is 300 millimeters and in the located in the center of the modules, it will not cause any shading on the backside. So next part is about the field data we have been working on in the last 3 years. So as LONGi is the first company to promote the bifacial PERC modules in the market, we started the projects very early time to work with those famous third-party lab to study how the backside gain can be maximized. So we have worked with RETC in America and with TÜV from Germany. We built several pilot projects in China, in US, in India, and in Saudi. So first, let's take a look at these projects in Livermore, California, where has very good sunshine. So there are 2 types of modules are installed on the 2P tracker. And the height of the central torque is 2 meters. And for the background, for the ground, there's a gray gravel by which the albedo is 21%. And then the system shows it has 8.3% bifacial gain from this pilot project. So next one is in Chennai in India, because India is always our most important market. So we also have a small project in Chennai. So the comparison is between 3 types of module technology. So the first one is mono PERC. The second one is bifacial PERC. And the third one is anti-bifacial. So the module is installed on a fixed tilt with 1 meter height, and the angle is 15 degrees. And after the system operation for 6 months, it shows that the bifacial PERC have a 19.2% energy gain comparing to the monofacial PERC. And also we find that the anti-bifacial also have a very good result. But considering the anti-bifacial is frameless, it's a frameless which has less shading. But as I mentioned in the beginning, it has a lot of transportation and insulation issues. So if the N-type is with a frame, we think the energy gain of anti-bifacial and bifacial PERC are very close to each other. And the next one is the feedback from our customer. This is the first bifacial order we delivered in 2017. This is a very long time ago. The customer has a big project with multi-modules with a fixed tilt. And they are trying to compare the bifacial PERC and the multi-modules with a tracker. So there were 3 different design of the system, one with a multi and a fixed tilt, and one with multi with tracker, and one with a bifacial PERC with tracker. And the system ran for 1 year, and it shows that the bifacial gain with LONGi's bifacial PERC modules are over 24%. And let's compare the field data with the simulation results for the same project. So you can see here's the simulation results. The energy yield gain by the PV system is 21.8%. So there is a 3% gap between the real field data and the simulation results. But considering that the baseline we used in the simulation is LONGi's mono PERC, not not the multi-modules. So we think the 3% gain is from the mono PERC over the multi-modules. So from this project, we think the field energy yield is can perfectly match the simulation result. Also, let's take a look at the degradation of the mono PERC modules. Here's a pilot project in Longji's factory. So from this slides, we can find that the first year power degradation of bifacial modules is only 0.55%. And after 1 year operation, the bifacial factors also remains the same level as its initial data. So I think this shows the stability and reliability of our bifacial PERC module. So the last part is about our new product series we will launch in this year. So firstly, this is our high-mode PERC modules, bifacial, monofacial and bifacial. We have two configurations. So first one is we use the M6 wafer, which is I think is the also a new wafer product in this market. So the module will be slightly bigger than the product with M2 wafer. And it can it can match almost the installation with the tracker or any kind of fixture. And here's the dimension and the weight of our bifacial high-mode 4 new product. So the cell will be updated to 9 busbar to minimize the power loss caused by the electrical resistance. And the module frame is without C-side at the short rail to minimize the shading effect caused by the frame. Sorry. And the module is glass structure with a 2 millimeter glass, and the bifacial factor will be around 70%. And its installation holes can match with almost all the tracker system. And for this year, the major power beam will be 440 watts. And our bifacial modules offers a very good power warranty. So the first year, the degradation will be within 2%. And for the coming 30 years lifetime, the annual degradation of the module will be lower than 0.45% every year. And here also shows the field data from our Longji PERC module. So this is from a third-party result. This is the first year of Longji module's degradation rate showed here. So for the last 3 years, the module shows around only 1% for the degradation. And here is our capacity. Here's our capacity roadmap. So I think we are speed up this this plan. So by the end of this year, I think we can already achieve our target of year 2021, and this 30 gigawatts. And this capacity will be compatible for both monofacial PERC and bifacial PERC. I think I'm very happy to share about the bifacial experience for us here today. And I think in last year when I travel around India so many times to introduce to our customers what is mono, what is a mono PERC. And I think from this year, the whole market of India will switching to multi to mono PERC. And today, I think after this good discussion, I think we can expect more market share of the bifacial modules in India in the near future. So that's all. Thank you.
Great. Thank you so much, Chris. Thank you for sharing your thoughts. And we have a lot of question and answers which you need to answer. I think meanwhile, we'll switch to Mr. Sai Charan from Jinko. Chris, you can choose to respond to the questions which are being shared in the Q&A panel, and you can keep responding. And my request to parts would also be, you can keep responding. Mr. Sai Charan from Jinko, over to you.
Thanks, Gurpreet. Very good evening to everyone. Thanks for sparing your time for joining this particular session. And it's much required at this particular point of time to make everyone to understand the importance of high efficiency technologies and the kind of shift which is what is required on the solar PV industry. Because we could see, as Chris was rightly saying, that last year, the same time, what we could see is that people were not in a position to accept any kind of new technologies with respect to mono PERC. So now that particular acceptance on the mono PERC technologies has came in. Of course, now everyone are going with mono PERC technologies, but within this, there is one more factor of bifacial technology acceptance is also widely required. And it just started, and we are very happy for that. And going forward, my complete presentation is going to be covered in 3 different parts. I'll just try to give you a kind of quick update with respect to our company. Jinko Solar is a global technology leader. I should say that because with respect to the shipment or with respect to the quality or with respect to any kind of aspects which are required on the technology aspects, we always stand as #1 in the market. And till last year, from the date of inception, we have delivered close to around like 50 gigawatt of capacities. And for this particular year, we have plan of crossing 20 gigawatt capacity on the module manufacturing line. So of course, we are a vertically integrated manufacturer in that particular aspect. And we have different products which are available within our kitty, wherein which we provide only high efficiency technology products right from the last quarter of 2019 calendar year, starting from 385 watt peak till 475 watt peak kind of power class. And all these particular power class are coming only in the mono PERC kind of technologies. And within this particular mono PERC kind of technologies, if we just try to see the market capitalization with respect to the acceptance on different cell size or different wafer size, initially market was standing at 156.75 cell size. Later on, Jinko is the first one who stepped forward in getting in 158.75 kind of wafer size. And we being the technology leader, everyone started following the footprints of going with 158.75 cell size. And that has become the standard for each and every module mounting structure manufacturers. Now we could see that most of the installations happens with the standard module mounting structure of 158.75 cell size. And that's the reason why we could see the acceptance of 405 is widely being recognized everywhere across the globe on these particular products. But yes, there is a wide need of the higher power class just to make sure that there is a kind of increase in the energy density, and not just limiting to that, but there are other factors wherein which if each and every end user will be trying to look out at lowering the LCOE part or increasing the IRR part, or getting the highest amount of energy yield, which is what is required at any point of day. So quickly going into today's session of bifacial technology, as Gurpreet and Chris, both of them has briefed about what exactly is the bifacial technology. It's the same. It's like for any kind of monofacial module, radiation absorption happens only on the front side of the module. But whereas for these kind of bifacial modules, diffused irradiance plus reflected irradiance both happens from the backside of the module. Because of that, instantaneous power will reflect in the instantaneous energy gain, finally accumulating for the higher energy yields when compared to monofacial kind of technologies. Quickly looking at the market share, way back in 2018, we could see there is a kind of top runner program which generally happens in China, but unfortunately not in India. The point is that these kind of top runners program is something that almost all high efficiency technologies will be accepted in these kind of tenders. Quickly, not later, very soon we also will be expecting the same kind of tenders from Government of India. Yes, with respect to this particular aspect, what we had seen, the statistical data is saying that in 2018, almost all the high efficiency technology acceptance has happened up to 3% with bifacial technologies. And this has been increased to 10% by 2020. And we were expecting within 5 years time down the line from now, we could see that this particular 10% can go up to 40%. And also last year we could see the acceptance of mono-PERC technologies is a challenge. That was a challenge. But now we could see there is wide acceptance of mono-PERC technologies with respect to full cell, with respect to half cell. Everyone are asking about the half cell kind of technologies on mono-PERC. Not just limiting to this, mono-PERC again is coming with these kind of bifacial technologies. Now it's again that wide acceptance on these kind of bifacial technologies has to be created, and which is what is required for the market to increase the energy densities. Because of the challenges, whatever we find and we face with respect to land availability and with respect to many other challenges, many other potential risks can be mitigated by just, going with these kind of bifacial kind of technologies. Looking at the platter of Jinko Solar, we have platter full of products on these kind of high efficiency technologies, starting from 400 to 475. If we just try to limit with respect to bifacial kind of technologies, we have 3 different series of all the modules. Cheetah, which is the standard mono-PERC kind of product on the monofacial modules. Swan is the bifacial technology product with the same mono-PERC of half-cut kind of technology. And Tiger is a new series altogether, which is called as styling ribbon, where in any kind of conventional solar PV modules, people try to go with flat ribbon kind of technology, wherein these kind of Tiger kind of technologies, which is styling ribbon kind of technologies, which has got the round ribbon, which means which will be in circular in shape, just going with a kind of flat ribbon, and on top of it going with any kind of light reflective material, LRT kind of materials, which generally reflects the light to absorb more amount of irradiance on the surface of the module, wherein which these kind of circular ribbon in shape, which are tiling ribbon kind of materials, if these kind of materials are going to be used on any kind of multi-busbar technologies, this immediately will reduce the spacing between the cells and also will increase the highest amount of energy yields, which is what is required. And someone was asking when there was a kind of a discussion which was happening from Chris, someone is asking what about the degradations. It's like with respect to these kind of bifacial technologies, and if we try to compare these kind of bifacial technologies with monofacial kind of technology, there is a wide variation with respect to lifetime. On all the monofacial modules, we could see 25 years the product lifetime guarantee which will be provided. But for these kind of bifacial technologies, it has got 30 years lifetime. It is all is happening just because of two important factors. The major important factor is that here, what is the encapsulant which will be used? It is not the same encapsulant what we will be using for the monofacial kind of modules. And also, this particular high lifetime on these kind of bifacial technologies is also due to the highest reliability factors, which generally these bifacial modules portray when compared to any monofacial modules. Thus, we could see that the first year degradation of these kind of bifacial modules starting from 2.5%, and year-on-year degradation is starting from 0.55%. So we could see that there can be a kind of wide range of change in these particular figures. Yes, depending on different class of application, these values varies. And yes, we provide in both the ways on these kind of bifacial technologies. One is with a dual glass kind of option, and the other is with transparent backsheet kind of option. If we just try to compare what is dual glass, why is it required, and why a transparent backsheet kind of model, what is the major difference or major sense, which is what is making here is transparent backsheet is a module which generally looks like a kind of conventional solar PV module. It is as similar to your monofacial module. But if you just try to look at these kind of bifacial module with dual glass, yes, it is going to come up with a kind of extra glass altogether. That is going to add some weight. That is going to add some extra cost. And also, whenever you try to install those particular modules of dual glass modules, you need to handle it very carefully. And also, why these kind of dual glass modules are going to be used? Because of two important reasons. What we can say is that the major important reason is the reliability factor. Whether the UV radiation acceptability on these particular modules is there or not. If that is not going to happen on any conventional module, they try to go with these kind of dual glass models. If the same UV radiation acceptability test happens on these kind of transparent backsheet models, yes, it is good to go with the kind of transparent backsheet models on the reliability factor. So one metric is covered. So the second very most important metric where bifacial dual glass modules will be used is in the abrasive kind of zones where they have got highest temperature zones and also sand flow is more. So for this particular thing, what we can do is we can even test the backsheet with respect to the sand particulate, the flow of sand particulates, if that goes more than 50 L or up to 50 L, if this test is being conducted on these particular backsheets, then it is even good to go with kind of transparent backsheet kind of models where in which this will completely benefit you in getting the highest energy yields, but also in reducing your capex costs. At the end of the day, what you will be looking out is whether my LCO is lower or not, whether my IRR is high or not. So these two factors easily can be mitigated with these kind of optimizations in these kind of bifacial technologies. So as I was telling you with respect to the Tiger products, because we in the Tiger series of ours, which generally comes with the 9 bus bar, which is called as a multi-bus bar technology. Again, it's always going to be with half cell kind of modules only, and also it is coming up with a kind of tiling ribbon technology. Because of that, cell spacing is getting reduced, and the low irradiance loss is also going to be reduced, and low irradiance loss and IM factor both goes again hand in glove kind of thing. If these goes together as a kind of hand in glove, definitely your incremental gain in the energy yield is going to be high when compared to any kind of technology of this kind of bifacial technologies. With respect to the power class on these particular modules on SWAN, as I was telling you, we have got two different high efficiency technologies on the bifacial products. One is SWAN series name, starting from 385 watt peak till 405 watt peak, and you could see this particular roadmap clearly explains this about this. Depending on your requirement, we easily can match your requirement, and specific to location, we can tell you which particular power class is going to make sense for you. And depending on the specific metric, whatever you want to know about these particular products. And on the Tiger series, starting from 455 onwards, 455 watt peak onwards, or 450 watt peak onwards, till up to 470, we could provide these particular bifacial products for this particular current calendar year kind of thing. So this is one of the kind of the best highest power class with the optimized cell design or the wafer design which you can see. And as I was telling, that these particular bifacial modules generally comes with the most important factors are the reliability factor, abrasive kind of zones, or any other characteristic which generally is helpful in getting the highest amount of energy yields. With respect to that, if you just try to see what exactly is happening between the monofacial module and the bifacial module. So within this particular bifacial module, instead of the encapsulant EVA, we are trying to replace with POE. Because this particular POE is a fluoropolymer which has got high hydrophobic in nature, wherein which it is highly resistant towards the stain composition as well. That completely eliminates the chemical composition or oxidation property of these particular materials, which is highly helpful. And similar to UV radiation capability. If you just try to see any kind of solar PV module, what kind of temperatures, what kind of humidity freeze is going to be experienced by the module. And also, if you just try to compare this particular product with any other existing monofacial product, we just need to understand what is the acceptable UV radiation limit. Acceptable UV radiation limit is one particular metric which determines the exact reliability characteristic of the module. Looking into that particular fact, what all is required is, if you are trying to look at for a kind of abrasive kind of zones where it's a kind of desert zone where sand particulates are high in nature, or if it is a kind of zone where it has got high salinity and high rusting kind of environments are prevail. So in those kind of conditions, what we need to see is, we just need to see what exactly is the middle PET layer acceptability of these particular UV radiation capabilities. We could see that from this particular slide, approximately 3,400 kind of kilowatt hours is directly getting exposed on the front side surface of the module. We could even justify that only 10% can be directly reflected to the backside surface of the module. Because of this particular factor, we could see the middle PET layer is hardly experiencing 15 kilowatt hours to 30 kilowatt hours. Even if you just try to check any kind of third-party reports, they'll be testing at 5 kilowatt hours per square meter or 10 kilowatt hours per square meter up to maximum of 15 kilowatt hours per square meter. So this particular metric is a factor to consider the reliability characteristic of the material. So this always helps in understanding the lifetime of the product, which is what is there with respect to transmittance factor as well. Similarly, we have tried in comparing both the monofacial and also the bifacial. Within bifacial, transparent backsheet versus dual glass, where what we have observed is the transparent backsheet has got better transmittance properties when compared to dual glass kind of options. As I was telling, it's a kind of abrasive test which has to be done with 50 EL constantly falling on the surface of the module, constantly falling on the surface of this particular backsheets, where in which this abrasive test generally happens in 3 different ways. But limited to our application, for the flat application, it is self-sufficient to understand whether this particular backsheet is going to withstand for 30 years lifetime or not, because the module is getting committed for the 30-year life. And this particular test of abrasion test is much required if you are trying to go for a kind of desert kind of locations. And also the other important factor is that which is much required. We could see the kind of application of dual glass applications is widely being asked for the locations like deserts or any kind of floating applications. If we just try to understand the major requirement, why they are asking for this. For these kind of floating applications also, as I was telling you regarding the application with respect to sand, anyway, abrasive test is self-sufficient. With respect to floating kind of applications, we always try to see what exactly is the water transmission rate, which is what is happening on the backside of the module. If that value is less than 2 grams per square meter, definitely it is good to go even with the kind of conventional solar PV modules which has got backsheet kind of applications. So these are the 3 important factors which are very much required to understand the applicability, to understand the reliability characteristic of any kind of module with respect to materials. So thus, we always try to see if the client has a kind of requirement, bare minimum requirement with respect to bifacial module on dual glass acceptance. Yes, we are ready to provide that. But also do understand the kind of benefits that what actually you try to get. You get with these kind of transparent backsheet applications as well, because it is not only just trying to provide you a direct savings, but also it is providing you a kind of direct benefits, which is what is required in the total entire lifetime of the project. And also, if you just try to compare the backsheet versus transparent backsheet versus the dual glass kind of application, the temperature application is also much lesser to transparent backsheet kind of applications. And we have done a kind of wide analysis on that. We have even tried in sharing a kind of white paper on that. So since we have limited time, I'll just try to quickly go through the other aspects where we have done some kind of analysis with respect to field installations of ours, where we have supplied for more than 3 gigawatt of only bifacial modules across the globe, wherein which we have tried in picking up few installation base just to showcase you what kind of advantages that are actually going to be there. So as both of the panelists have already shown that what kind of energy gains can be expected with different surface texture albedo factors. And of course, albedo factor is a diurnal curve which generally varies throughout the day. And the moment you have high soil resistance, definitely you have high reflectivity indices. Because of that, you will have more extra amount of power which will be generated because of the extra diffused irradiance which will be hitting on the backside of the module. And this is one particular case study which we tried in doing, just comparing the monofacial module versus bifacial module for constantly for 4 or 5 months. What we had seen is that there is a kind of fixed tilt system on a sand application where we have created in our existing Henning factory. And what we have observed is like close to around like average of 11% of energy gain has been observed. And similarly, we have done with single axis tracker for the same kind of location where we had seen more than 12% of energy gain has been observed on these kind of monofacial versus bifacial. Similarly, we have done the same kind of application on grass. There also we have observed not less than 10% kind of energy gain. So these are different applications where we tried in comparing bifacial module with a monofacial module. Yes, there is an absolute gain. There is no doubt about that. There is an absolute gain. You go with grass kind of application, where in which your grass is having a kind of albedo texture of not less than 20%, where in which you try to go with a kind of sand where yellow factor is going to factor in, where in which it will add much more energy gain when compared to any other applications. Similarly for snow. Also, we have not just limited only comparing monofacial versus bifacial. Within bifacial, we again tried in comparing bifacial dual glass versus bifacial transparent backsheet. You could see on the complete extreme right hand side the kind of gains what has been noticed with transparent backsheet models and compared to bifacial dual glass kind of models. On any kind of application, we could see that a minimum of 0.85% on a kind of fixed installation and not less than 1.5% on any kind of tracker kind of application. This is a kind of eye-opener even for the industry to widely accept, not just to go with a kind of specific requirement of glass to glass with 2.5 mm thickness or 2 mm thickness kind of glass. Yes, we need to understand the kind of metrics what are required to be cleared for that. If those are getting cleared with the requirements of highest reliability factors and the metrics which can be tested on these kind of parameters, and if they are getting cleared, definitely acceptance on these kind of conventional type of modules adds much more benefit to the value end players who are supporting these kind of entire PV value chain. So similarly on, as I was telling, this is a kind of comparison on fixed tilt kind of location, wherein which bifacial dual glass versus bifacial transparent backsheet, where we could see 0.85% gain is completely being noticed here. And on sand with a tracker kind of application with 1.62%. As I was telling in the beginning also that because there are certain other parameters where the dual glass is not having those kind of properties when compared to transparent backsheet kind of models, wherein which under any kind of irradiance pattern, you could find this particular graph clearly explains that under any kind of irradiance pattern, the amount of energy generation is going to be more for transparent backsheet kind of models, but whether that can be Swan transparent backsheet or Tiger transparent backsheet, any such kind of models which will be highly helpful and useful. So this is what I just thought of explaining much more with respect to these case studies, but because of time constraint, I want to limit and restrain myself till here. And thank you so much, Gensol Group, for this.
Thank you so much, Saicharan sir. It was a very insightful presentation. I think you have accumulated a lot of question interest from our participants. So spend like next 10-15 minutes answering to most of them. Okay, quickly to Mr. Parth. Saicharan, I would request you to end the screen share and the Parth can switch on. And my request to Chris and Sai sir would be keep answering a lot of questions since we are running late on time. We will shrink the Q&A session and keep it minimal, the questions that we'll be answering live, but try to answer as many of them as possible on the Q&A forum. Parth, you're able to share your screen?
Yeah. Can you see it?
Yes, absolutely. All yours, Parth.
Okay. Okay. Good afternoon, everyone. It's a pleasure to be present here and represent my company and bring out our perspective on what this new technology is going to bring out in the market and the field that has just started flourishing, and it is unleashing all the new variants or the technologies that it has. So I hope that everyone is safe and sound in this situation, and with this I would like to start my presentation. So first I'll be explaining about the company. We are in the industry since last 30 years, and we have a 2 gigawatt module manufacturing unit here in Gujarat. We have shipped more than 3 gigawatt modules globally. We have done more than 7,000 different projects for rooftop, pumps, and telecoms. Our products are exported in more than 30 plus different countries. We have also commissioned 600 megawatt plus EPC projects. We have over 35% CAGR year-on-year growth, and we are also enlisted as the Tier 1 solar module manufacturer by Bloomberg since last 19 quarters. We also have recently entered into energy solutions, wherein we offer different types of batteries like VRLA batteries, lithium-ion batteries for different storage applications. We have more than 300 different sales and service centers spread throughout the country to provide local service to the fellow countrymen. We have more than 2,500 employees in the country, and we are India's largest module manufacturer. So this is a glimpse of our...
Please, we have this request from a lot of participants.
Yeah, what?
You have to speak a little loudly. Participants.
Yeah, sure. I'll do that. Okay, so this is the overview of our factory. It's a fully automatic production line, and the line is capable of manufacturing all different latest variants of modules, that is bifacials, the half-cut bifacial, glass, all different types of modules can be manufactured with a single line. We also have a state-of-art laboratory that is CTF approved, both for raw material testing and other reliability testing for our modules. And we also have a specialty in making flexible modules, that is the Merlin modules, and we also offer AC-based modules, that is the microinverter ones. Apart from that, we have been fortunate to have some renowned global certificates, that is certificates from ISO, IEC. We are also having associated with Bifacial, that is for recycling of the PV modules. We have our company is certified by CEC. We are UL listed. Our modules are also certified by Green Pro. And we also have successfully completed some reputed third-party audits like Black & Which, ICIM, CEA, Intertech, and PI Berlin, and IC. Our products are financed by more than 20 plus different banks throughout the country. The list goes on. So, understanding the bifacial boom, I think all of my colleagues have explained much in details about what the technology is and where it came from. So I would just like to add up one or two points to that. This is the slide wherein I'm showing the world market share that is being predicted by ITR PV, that is International Technology Roadmap for PV modules. And we can see here that by the end of this decade, the roadmap shows that the bifacial is going to be the mainstream technology. So that's why there is this interest in this technology. And again, on the right, we can see that the bankability of this half-cut and bifacials is still, making a lot of, giving us a lot of clarity, wherein, these technologies are, yes, bankable by, BNEF, Bloomberg. So these are the reasons why the interest have diverted towards this technology, and everyone is really moving towards that direction. So why these changes happen? So one of the easiest possible thing is that it's very easy to make bifacial solar cells out of the mono-PERC solar cells. All you got to do is just add 3 different process steps, and the same line that makes a mono-PERC cell can be transferred into bifacial mono-PERC. So this is one of the prime reason why this technology came into the mainstream market. And another important parameter that I would like to discuss over here is how to rate these bifacial modules. So we have been quite acquainted with the knowledge that all the different modules are rated at their STC conditions at 1000 watt per meter square and 25 degrees Celsius and air mass of 1.5 G radians. The modules are rated, but when it comes to bifacial, there is a lot of confusion going on in the international market, wherein how to rate these modules. Should one consider the front side irradiance? Should one add both front and the rear side? What is the right way to do it? So IC is just coming up with a draft standard and coming up with a new standard, which is yet in draft stage. And some of the possible mechanisms or possible solutions could be that wherein one of the solution is like you consider the single side illumination for the front side, and then you add up the ratio of the current for the rear and the front side, or you consider 200 watt per meter square of irradiance from the back side, and you add it up, and then that gives us the total power output of the PU module. That is, if you have a bifacial module of 300 watt peak and at So 300 watt peak is at 1000 watt per meter square, 25 degrees Celsius from the front side. For the rear side, we need to illuminate it at 200 watt per meter square, and at the same temperature, whatever is the power output, we add both of them up, and the final output should be the could give us a better idea about how these bifacial modules can be differentiated. So one of the draft methods that IEC is about to propose is this BNPI, that is bifacial nameplate irradiance, wherein you consider 1000 watt per meter square for the front side and 135 watt per meter square for the rear side, and you simply add these values up, and the value and the power output that you get should be rated for the bifacial module. So this could be one of the possible ways wherein we can differentiate between different bifacial modules based on different technologies, and also it could give us a really good idea about how the bifacial performance would vary. So briefly about our product range, we offer right from 3 watt peak to 400 watt peak of PV modules, and especially for bifacials, as you can see here, we also have shifted to M2.5, that is 158.75 based mono-PERC cells, and our 400 watt peak series is both the monofacial and the bifacial variants, and we offer them for at a 400 watt peak range, and we also offer different standard modules like the standard full cell bifacials, the flexible and foldable modules, and standard modules. So when you compare this this new 158.75 or the M2.5 wafer size, or even G1 size, that is the term used in the industry these days. So when you compare these enhancement in the sizes, yes, there is an enhancement in the efficiency, and when compared to different our traditional poly and traditional mono technology, we see that utilizing these technologies can reduce your specific yield can increase your specific yield by 4%, and also decrease your area by 23% when compared to traditional poly, and that for mono it's your specific yield increases by 3% and area again reduces by 5%. So definitely there are gains there when you shift to larger sizes. So these are different bifacial variants that we offer. First is the unframed bifacial modules. So we have two variants here. One is the full cell bifacial module that ranges from 380 to 395 watt peak, and the other one is a half cut bifacial module that is ranging till 400 watt peak. So both of these modules utilize the latest M2.5 mono-PERC cells, that is the full square mono-PERC. Another variants that we offer are the framed bifacial modules. So in the framed one, we offer the same full cell and half cut variants, both glass framed and glass transparent backsheet framed. So the first one here is the glass framed bifacial module that ranges from 380 to 395 watt peak. The Super 400 Pro is the glass framed by half cut bifacial module that ranges till 400 watt peak, and the last one is the super bifacial, that is the glass transparent backsheet framed module, and it also ranges till 400 watt peak. So depending upon the different user applications, we have all the possible variants of bifacial one could think of. So coming back to the Indian perspective, India is a country that is divided into 6 different climatic zones. Here we can see that we have 6 different climatic zones, that is the hot and dry, warm and humid, composite climate, moderate, cold and sunny, and cold and cloudy. So we decided to test these or simulate this by different bifacial systems for these different climatic zones, and understand how these different climatic zones will play their role in determining the performance of the bifacial modules. So we carried out this study, and below are the following assumptions that we have considered. We have considered 3 different technologies, that is the polycrystalline technology, the mono-PERC technology, and the bifacials. For polycrystalline, the modules considered were 325 watt peak, for mono-PERC 380, and bifacial was 400. All the power plants were having the same capacity of 1 megawatt, and all were fixed tilt. The tilt was determined as per the latitudes of different power plants, and factor of shadowing was considered as 1.5. For bifacial, yes, we have considered some additional factors, like height was above 1.3 meters to get the best gains. The GCR was around 45%, and the ground, the surface was concrete, which has an albedo of around 30%. And these are some of the results of these simulations. We can see here that when the bifacial plants are deployed in these conditions, in these different climatic zones, in all 6 climatic zones, the bifacial modules stand out as the best performer. And we can see the differences here. We can see that bifacial modules have generated more than 83.8 megawatt hour per megawatt to almost 200 megawatt hour per megawatt in entire throughout the country. That is, if you consider in terms of gain, then one can expect like 7 to 8% of energy gain just from bifacial when compared to both these technologies, poly and mono. Also, again, utilizing this bifacial module, the energy output when quantized is roughly summing up around 1600 megawatt hour per megawatt to almost 2000 megawatt, that is more than 2 gigawatt per megawatt. And again, we can see that a rise in PR of all this power plant, could range up to 5%. So it is quite clear that these technology is having its own gains. To further, understand it in terms of savings, we can see that, there are potential savings also associated with this technology when, comparing with both bifacial versus poly and bifacial versus mono. We see that obviously the savings are large enough when compared to bifacial versus poly. So it roughly, on an average, the savings are more than 11% when compared to the polycrystalline technology for all these climatic zones. And this, when compared to the mono PERC technology, the savings can be as high as almost 5.5% or 6%. So in terms of amount, you can roughly consider it as, the savings range is right from 3 lakhs to like almost 115 lakhs. So that is more than a crore per megawatt can be realized when you utilize this technology. So, it makes a big difference when we utilize this technology at different climatic zones. Here you can see that for composite climate, the difference is quite high when you compare when you differentiate between the mono and the poly. For bifacials, again, for hot and dry, the generation is quite high. So these differences are significant enough to justify the importance of the technology. So to conclude, I would say that more or less, there have been many field studies and many simulation studies to prove the value of bifacial technology, that it is definitely set to give us higher gains and again lower our LCOEs. Again, rating of bifacial module is still under study, and we expect that very soon we will have a solution from the IEC by next year, and there will be clarity about how these modules are to be rated. Again, utilizing the bifacial modules can really enhance the power output. There is no doubt in that. That is for sure. Again, when you use different albedo factors, might well we have considered a concrete ground in this simulation. If we further use surfaces having higher albedo, then the this gains could go even more beyond the range of 6 to 8%. And while one of the important aspect is that now the world is no more focusing on INR per watt peak or dollar per watt peak thing. The game is all about INR per kilowatt hour. So eventually LCOE is what matters. So there is where bifacial technology makes an obvious choice for the end customers or the EPCs. Yes, that's it from my side.
Thank you so much, Parth. It was very, very insightful from your perspective, and especially on how the upcoming tests are going to look like for bifacial, because my understanding is that in the commercial establishments, they are tested on one side. Good insights on that, and also from an India-specific environment, how they're going to look like. So thank you for that. And I'm going to, we have a lot of questions and answers which were asked, and we're going to continue the webinar, although we have overshot the time. and I'll ask one question each to each of the panelists, although they have replied to a lot of them. And meanwhile, I'm just launching a poll also. Would request you to take just 10 seconds and give us a feedback on this. Uh, my first question to Chris would be, and most commonly asked question, Chris, was that we need your comments on degradation. And a commonly asked question was that how does degradation, both PID and LTTD, look on this bifacial? And also, is there a rate of degradation difference which is there between the front side and the back side? So yeah, Chris, over to you to answer this question live.
For the LID that we think is included in our first year degradation rate. So we recommended it will be lower than 1.5%.
Okay, and any differences on the front side rate of degradation and the back side?
The back side degradation will be a little higher than the front side.
Okay, and if you could just tell them in little technical terms, why would that be?
I think we have done a lot of research on this. I think the backside, because of the, this is not about the LID, but I think I can, how to explain this?
So we can always respond back them with some pretext and theoretical analysis of that, if you would like to.
Yes, sure.
That's absolutely great. Thank you, Chris, for answering that. The question to Jinko, Mr. Sai, would be two. One thing is a lot of questions were that how to simulate this in PVSYST, and do you feel there's a difference which is coming in simulating bifacials in PVSYST versus your on-ground experiences?
Right. So with respect to simulating these kind of bifacial modules or the pan files of these bifacial products in the PVSYST, the algorithm itself is accepting it. But yes, there are certain other loss components which has to be captured in, like the mismatch loss on the rear side or on the shading loss on the backside pattern. So few parameters has to be added while doing the simulation. It can be mitigated and it can be done through. And second part of your question, you were asking, sorry, I didn't follow it. Could you please repeat the second part of the question?
Yeah, and do you find, so this is around the PVSYST simulation, but in terms of what PVSYST throws out the numbers, the projections that it's throwing out versus the on-ground performance. So
yes,
how
absolutely. Absolutely, got it. So coming to the point of what exactly is the delta between the PVSYST simulation report versus the exact actual on-ground result. Yes, there is always a kind of increment than what your PVSYST number throws out. The reason is that if you just try to see within our previous slides itself, on the sand kind of locations where in which we could see the albedo factor of only only up to 25% to 30% of albedo, where the kind of energy gain is showcased there as 9%. Similarly, for the greenfield applications, where if it is a kind of grass, for all kind of grass applications where the albedo is ranging in between 20 to 25% for the same albedo factor, where the energy gain is limited only up to 5%. This is all is happening because of the yellow factor, which cannot be directly determined through the simulation as well, because the algorithm of the PVSYST could not even capture most of the parameters wherein which the actual site conditions are not capturing. And that's the reason why people have many apprehensions whether are we going to get the same amount of value of PVSYST values or not. Yes, absolutely, because almost all our applications and all our installations, which all are there existing across the globe, we had experienced that at on the higher side only. So it is always possible.
All right. So to address the curiosity of our participants, and what Citroen tells us that PVSYST gives this not on an optimistic level. If PVSYST is throwing out a number, you're going to get more than that and not less than that. That is what their field trials have given them, and the big projects that they installed. Citroen, another quick question to you. A lot of people were asking around the pricing of these panels. So I would like to have a perspective on this, that a single facial, monofacial, mono PERC cell half cut versus bifacial, with a transparent backsheet versus a frame? How do you see the price delta? I can understand absolute
Yeah,
pricing terms.
you're absolutely asking a right question to a wrong person. But yes, I'll try to I'll try to answer your question in crisp. So comparing monofacial module versus bifacial with a transparent backsheet kind of model, because that is not going to go with dual glass option. So
Right.
a kind of delta of 1 cent can be expected for any kind of monofacial to bifacial with transparent backsheet. If you're trying to go with a kind of transparent backsheet versus a dual glass, where you will be having 2.5 mm of thickness of glass on both the sides, or 2 mm thickness of glass on both the sides. For these kind of options, since glass is getting added, you could expect 0.5 cent to 1 cent extra on top of transparent backsheet models.
All right. So in
But
total,
yes, this you need to just underline. I'm not the right person on the cost parts, but this is a kind of generic value which I could.
ballpark is fine, right?
Yeah,
I think the world around is going on estimations right now. So, okay.
right.
Quick question to Wahid, Mr. Parth. A lot of people were asking regarding the rooftop applications for bifacial. How do you see that market? How do you see? So we have Longi and Jinko contributing a lot to the ground mount systems. How do you assess the rooftop scenario for bifacial?
When you consider the rooftop scenario, the first and foremost thing is like, we cannot install these modules at a particular height from the height. So, where in the ground mounted system, we have seen in the presentations from both Tinko and Longi that, the moment you increase the height, your bifacial gains are going to increase. So we need especially a minimum height of 1 meter has to be there in order to reap off the maximum benefits from the bifacial. So, when you consider rooftop, then, this will always be an issue. So I guess utility scale is the best case scenario where you can reap off the maximum benefits from bifacials. Also, you can consider trackers in this, but for rooftops, there will always be a challenge. The moment you increase the height, then again, the wind factor and load factor comes in, and then you need better structure, and the challenges increases. So there is always a problem for rooftops, but for utility or ground mounted, yes, this is a base case scenario.
Okay, so how I understand is then from the shed perspective, where we are putting a shed installed modules, right, where you're just almost pasting them on the rooftop sheds, the metal sheds, is going to be difficult because your rear side is not exposed at all. Whereas when we go to the RCC installations, where anyhow you're putting structures of whatever half a meter, a quarter of a meter, 750 mm, I think there it can be still explored on a case-to-case basis. I saw Chris reply to one of the guys. He asked that, how do I install on roof? She said, you just paint the roof white, right? It is easy. We see a lot of roofs being painted in India as white to prevent the overheating. So I think that could be a good scenario where we land up. Chris, one last question to you also. A lot of people were asking around the cleaning of these modules from the backside. What are your thoughts on that?
Excuse me, what's of the backside?
The cleaning of the modules from the backside.
Cleaning. So for us, we recommend it once a year to clean the backside of the module. So we already installed a lot of bifacial module in West China, where the air is not that good enough, and then there's sand, a lot of dust there. But it shows that the backside, the surface is much more cleaning. It's much more clean than the front side.
Okay, Jinko's perspective on that?
Yeah. So for these kind of transparent backsheet models, if you just try to see, it's finally at the end of the day, it's PVF material. All F component materials is less exposed to attract any kind of dust particulates. So in that particular scenario, we could see absorption or accumulation of dust on the backside or the rear side of these kind of sheets is highly, I should say that it is having high resistance towards that. So in that scenario, if you are trying to clean front side for around like twice in every month or 4 times in every 2 months, once in every quadruple times is self-sufficient. Just to wipe off with a kind of soft and smooth cloth is sufficient.
Okay, amazing. Last question to Wari would be, Parth, you mentioned about testing an upcoming standard. I think if you could just repeat that standard for our participants, what is the upcoming standard on testing both sides of the bifacial modules?
Yeah, so it will be a new version of the IEC 60904-1-2, the testing standard for any modules. So therein, the concept of BNPI, that is bifacial nameplate irradiance, will be there, wherein, for the front side, it is the same STC condition. You need to measure the module at STC conditions. Be sure that the rear side is, a non-reflective side, wherein you have something which is non-reflective on the rear when you measure the modules. And for the front side, that is 1000 watt per meter square. And again, you add up the value of the rear side at 135 watt per meter square. So the summing up of values of power output at both these irradiance for front and rear side would, give us the estimate of what this module should be rated at.
Okay, great. Thank you, Parth. And sorry for every participant's time. We took a little more than expected. There were a lot of questions which we would still love to answer. I think we'll try to answer them over emails to all of you, along with our panel of experts. Thank you so much. Thank you, Chris. Thank you for coming. Thank you, Mr. Sai Charan from Jinko. Thank you, Parth. I wish you all the very best. Stay safe, stay in house. And it's a very unpredictable world outside. Same applies. I remember a question, somebody asking that, how do you see bifacial getting coupled to COVID? My response on that is, I think everything is coupled to COVID. Elections, numbers, economies are coupled to COVID. Maybe that could be one of the sessions we'll do after 1 month to reassess where do we stand. But thank you so much. Thank you. It was a pleasure having you, and thank you for sharing insights with the participants.
Thanks,
Thank you.
Thanks all.
Thank
Thanks,
you.
Gensol Group.
Yeah.
Thank you.
Bye-bye.
Yeah,
Bye.
bye-bye. Thank you.